Hello, this is Latrell Jackson of Knowledge Over Grades. And just 1 second, I'm going to go live on Facebook and we're going to get started. A live session to do guys on on quadratic equations. Hello, Facebook. So live. Hopefully you can see me on the screen. Oh man. Okay, I'm gonna try this again. 4 ways to not 4 ways, but 4 steps. Sorry about difficulties. Hopefully you are bearing with me. I appreciate it. Awesome. All right, so we're live on yes. So let me hello. I am green my so I got all set up. Sorry about my lateness. Hopefully my connection is okay. Sometimes I'm blanking in and out. But I wanted to talk about graphing quadratic equations because a member of the Facebook KOG Math Achievers Club um, asked me to go over this for because she's having a final exam for her college algebra class on Friday. So real quick, I wanted to and do something exclusive for you all so that we can understand this aspect of algebra because there's several different aspects to algebra. I've come up with 4 steps to graphing to oops, quadratic. And the 4 steps are actually what precedes the actual graphing part, but these 4 steps are really important so that you can just when you get to the graphing part, it's just straight up plotting points and going into creating your parabola. So a quadratic equation, if you're not sure about what that is, it is a equation in the form of x squared plus b a quadratic equation. Sometimes you will see um, sometimes you will see y plus b, right? Okay, cool. And sometimes you may need to factor. You will need to factor, and there are different ways that you can do the factoring. You can do um, just regular factoring using the AC method, or the um, factor by grouping, or guess and check, which I've gone over in previous live homework help sessions, which you can go back in the group and see which ones are labeled factoring polynomials, because that's what this is a polynomial. It's just to the degree of 2, like the degree of this equation is 2. And you can also do, and that's what I'm going to use today, because since I've done the other versions of factoring, I want to do completing the square because I haven't done that yet. Thanks whoever's watching for hopping on, and show you how to do it that way so that you can have another method under your belt to graphing your quadratic equations. So I don't know who that is. Please give me a wave. Hey, okay, hey girl, hey Diana, and this is like the video that you wanted. So I'm asking your answering your questions. Um, so here's a standard form equation, and what I'm gonna do is take an example, use the completing by use the completing the square then graphing the function on Desmos.com. If you have not discovered Desmos.com, this is amazing. It's an amazing website. It's basically a graphing calculator online. There's also an app for it. Okay. I will also post about it in the group so that you guys can just go straight to it and start using it. But it's super, super useful and important, especially if you don't have a graphing calculator on you, but you want to use one. It's very helpful. Okay, so let's use this example. Blue. This example. So here's step one. I'm gonna call it step A, actually. Sorry for my. So um we have this equation: x squared 15x equals. All right, cool, nice. So in this situation, I'm going to use completing the square. And when you are completing the square, you actually want C. So C is that constant. You want C to be on the other side of the equation where 0 is. And that way you can do what I'm about to do. So completing the square, it take is all right. So let's identify what A, B, and C are so that we can plug in the right letters. So because A is always in front of um, my computer died, my other one. A is always in front of x squared. See, and then and positive 15. We move this C over to where it's supposed to be. If we add it, it would be 15, positive 15 on the other side, and equal to 0. C is in this correct place in the standard form. It's not in this correct place here. So let me go. Let me join my live on my phone real quick so that I can see if I have any questions or whatnot. I know Diana's watching. If you have any questions, go ahead and ask. All right, so I joined on my phone. All right, so with this little 2a. This is going to give us our new c. And we're going to plot that in right here at 16x. We're also going to plot 15 on the other side, and I'm going to show you in a second. So is negative b over 2a, positive b. B over negative b somewhere else in this process. So b is negative over, ooh, this is wrong. It's actually squared. B over portion of the equation. And I got it right here in my notes. It's b over 2 squared, and I just didn't look at it. Okay, so b over 2 squared, 16 over 2 squared. So negative 16 divided by 2 is negative 8 squared is 4. Okay? Yay, we got it. I'm watching. My Wi-Fi is being crappy. I see you, Diana, going in and out. So don't worry about it. It's recorded, and you can watch it later on. Appreciate it though. So my Wi-Fi is a little crappy too, actually. So is and we're going to rewrite our equation using this 64. So 16 as our, we have a new expression right here that I just wrote is actually a perfect square trinomial. And you're going to see in the next steps how it becomes a perfect square. We can use square rooting and everything to simplify it and solve for x. And then what so this does is balances out that the fact that we're adding 16, because we can't really just add 64. We can't really just add 64 to one side of the equation because that's changing the equation totally. But if we add 64 to both sides, we're basically just adding 0. We're not really adding anything, right? Because if we subtract 64 on both sides, you end up with 0 and you end up with nothing. Like, it's basically adding 0. Okay, so retract. Okay, so now what we can do, simplify this side. So 64 minus 15, and then we can factor this side, the other side. The AC method, which is also factored by grouping, and you can also just do the guess and check. So I'm going to use a guess and check because it's kind of obvious it's going to be. You want the factors, two factors of 64, that to be negative 16. So what they're going to be is negative 8 and negative 8. Negative 8 is positive 64, right? And then negative 8 minus 8 is, or negative 8 plus negative 8 is negative 16. And so there you go. The other thing to note is that you have, hey Bonnie, thanks for joining. Another thing to note is that you have a binomial that is the same in both pair of parentheses of this quadratic equation or expression. You can do when you have something like when you have 5 times 5, right? X minus 8, so we can rewrite that as minus 8. What we want to do is we want to solve for x. Okay, so we solve for x by releasing it out of this squared situation and then getting the negative 8 out of there. So first we got to by doing the opposite of squaring, which is square rooting. So we square root 49. Then what we do is this squishes out this c. The other side, we square root 49. Square root of 49 is it is, but it's actually or minus 7. We plus 7 and minus 7. Plus 7, so if we do 7 times positive, right? Negative times negative is positive. So in this situation, we're looking for both positive and negative 7. We All right. So what we're going to want to isolate the x again. So we got to get that negative 8 out of there by minus 8 and add x by itself. And this looks interesting, right? We got positive 8. We got plus or minus 7 plus 8. I'm going to write it like this. 8 is positive 7. This is going to give us two answers because we have to do 8 plus 7 and 8 minus 7 because it's plus or minus. So I'm going to list this as x1 is going to 7. 8 plus cool. So guess what we just did? We just found our x-intercepts, the x-intercepts of our quadratic equation, our quadratic function. In quadratic, it can either be facing up or down. They're on the graph, but it looks like a parabola, a U or upside down U. And what we just found were the x-intercepts. So one will give you see the y portion or the y coordinate is the y value is 0 because we don't go up or down. The x-intercepts are basically where the so 1, which is 15, 0, and we found so those are the points at which the graph crosses the x-axis at the x-intercepts. Okay. Any questions? Let me know. Now I'm going to go on to the first step. Now we need to find the y-intercepts. So basically, the y-intercept is where the line crosses the y-axis. This graph that I drew is not just what we're about to do, what our graph looks like. I should draw over and make it look like what it's like. Hold on, let me um let me clear the screen. That'd be quicker. All right. So Friday is our product. And if we start equation, um, at the spots they're supposed to be. We got 1, 0, we got 15. Y-intercept, y-intercept is going to go like this. So what we need to do is rewrite the equation squared x 15. All right, so now we need to put our equation, our quadratic equation, in the standard form. The standard form x squared plus bx. So our plus c is on the equation. So in our situation, our plus c is on the right side of the equation. So we got to move it over to the left side, 15 on both sides. So we got x squared, x. Cool. It looks like the standard form. Now what we can set it equal to y. So instead of having 0, we're going to have equals 16x. All right. Another thing I want to point out is that y is this right, because y is always the dependent variable. Y is always dependent on x. Whatever x does, y is like, all right, I'll change based on what you do. So y is a function of x. Why I said f of 0. I didn't mean f of 0, I meant f of x. But we're going to end. I jumped ahead of myself. Y is a function of 0. Y is a function of x. Okay? So that's equal to y, which is equal to the equation. That's why I wrote it like that. We're going to do whenever you see f of x, or I mean f of 0, 2, or f of 12, all you're doing is plugging in, replacing x with that number that is f of something. All right. So put 0. So we got 0 squared minus 0 plus 0 squared is 0. 16 times 0 is 0. And all we have is a plus 15. So y is equal to 15 when x is equal to 0. Is our our y-intercept. We turn this into a point. Intercept is 0. So this is where our graph crosses. Okay, it's really cool. You don't even have to do all of this. All you have to do is say my y-intercept is 15, because that when you plug in 0 for x anywhere else in the equation, is going to turn to 0. 0 times anything is 0. And the only number that doesn't have, or the only term in the equation that doesn't have an x connected to it, is the constant, is c, is 15. So whenever you have a quadratic equation and you're trying to solve for the y-intercept, it's always going to be that constant. That's how it goes. But I had to show you the correct way to do it so that you can see that that's how it works. All right, so we got our, that's the second step. This myself. and here. The y-intercept is 0, 15, 15. 1, 2, 3 points. We got the y-intercept and we got the two x-intercepts. There will always be two x-intercepts in a quadratic equation because it's a parabola, and a parabola goes through comes from up, goes down, and comes back up if it's positive, or if it's negative, it comes from down, goes up, and comes back down. So it crosses the x-axis twice. Okay, let's look at C. C is where we need to find the vertex. What is the vertex? So, like I said, this is a parabola. The vertex is always the minimum point on the positive parabola, or the maximum point on the negative parabola. Um, so it's basically where the curve is, where the change starts happening. Because first it's going down, then it starts to change and start going up. So you want that point right there. That's going to help you to determine where your parabola is changing. The vertex is a point. A lot of HK, and usually you use HK when you have the vertex form. I'm doing I'm using the standard form. So to turn out to be an XY form, but it's going to be the same point. Whatever form you use is always the same point either way. If you're working on the same quadratic equation. So vertex of the parabola, we start with the x value. X value, we need to, and this is what I was getting confused with in the beginning when I was doing completing the square. I was getting it mixed up with this. But negative b over 2a is the correct and the x value of our vertex of our parabola. So, like before, we said that is 1, because here's our equation again: x squared x. Okay, negative b over 2a. So negative, the b is 1. Cool. All right, so I'm going to keep the negative out here and work with the fraction first. By 2. Negative 16 divided by 2 is 8. And a negative 8 is actually positive 8, because this is actually negative 1 times negative 8, which is a positive. So our x value of our quadratic equation is 8. Put that here. So how do we find the y value? Well, we take our x value and plug it into the equation to give our y value. Instead of having say equal to 0, I'm going to have it say equal to y value. Y value is going to be, instead of x squared times 8 squared is minus 16 times 8. I think that is, I didn't write it down. I think that is 128. 16. Yeah, 128. Okay, cool. Now we just add and we end up with 9. Negative 49. That is our y value. So now we can plug that point. Let me make this a new color. First, negative 49. So if we go to the graph, and I'm going to take this and y'all down, like way down. I'm gonna just put it here though. So this one, I'm gonna just right here. Let's see, that's 8. Okay. Find the D. The axis of symmetry is basically the line that goes through the middle of the person. So the line is a vertical line. And what do we know about vertical lines? Well, vertical lines are x equals something. So they're not in the standard linear y equals mx plus b form because they don't have a slope and they don't have a y-intercept. So unless it's the y-axis and the whole thing is a y-intercept. But the the axis of equation of a vertical line is always something. So I'm gonna say it for right now. Um, what is equal to is going to be the number that it passes through on the x-axis. So it passes through 8 on the x-axis. Axis of symmetry is x equals 8. Think about it also, it goes through the vertex, and the x value of our vertex is 8 also. Another way to tell what the axis of symmetry is going to be, like how you can foresee it. Okay, so that's all the steps. That's 4 steps, A, B, A, and we have everything we need. We plotted our points as we went along, and let's go ahead this so crazy, y'all. But there you go. That's your parabola. You don't have like a graphing calculator, or you're not on the computer and you can't use Desmos. These are the steps that you need to take in order to go ahead and plot your points immediately as you go along. So all you need to do is just graph your parabola. Any questions? All right, so what I'm going to do is go to Desmos. Hold on one second. X this out real quick and start over. So this is Desmos.com calculator, and it's easy to use. It has a bunch of functions down here for you to go ahead and type stuff in. And what we're going to do is I'm going to show you how to type it in. So all you need to do is press X for our equation. Our equation is x squared. So we go to this button where it says a to the b. We can also do a to the 2. A to the b is like if you have an exponent that's more than 2. So we can do a to the 2. And then I would press plus. You can either press plus here or on your keyboard. Plus, what's the equation again? Is it plus or is it minus? It's minus. So press minus 16 x. You can press x on your keyboard as well. Plus 15. Plus 15. Okay, that was pretty simple, right? And this is our parabola. This is what I drew. This is a more accurate version of what I drew. And as you see, this point right here is 8, negative 49, which is the vertex. Here's our first x-intercept. Here's our second x-intercept, 15, 0. And then our y-intercept is 0, 15. And there you go. Simply wimply. So if you have any questions, please let me know. I'm glad I was able to show you this. It was a lot of fun. Math is fun for me, guys. And have a great day. Hope you do, Anna, and everybody else who's taking final exams. I really know for you during this time of the school year, and I just wish you much success. Make sure you're getting your rest because I know that it can be stressful. Make sure you're eating right. I know when I was taking finals, I probably took never really go to sleep at night because I was studying so much. So my heart goes out to you. I'm thinking about you, praying for you, and making sure that you're taking care of yourself as you're also making sure you're studying and getting what you need so that you can pass your final exams. All right, everybody. Have a great day, afternoon. I'm about to go tutor at a high school in my hometown, Trenton, New Jersey. And I actually should be in the car right now on my way because it takes me 30 minutes to get there and it's 2 o'clock right now. All right. Bye, everybody. Talk to you soon. Trying to end this.